Decision tree analysis.
Another technique that allows us to make risk management decisions based on evaluating expected values for different possible outcomes of Figure 8.6, Example Best Case. Figure 8.7, Example Worst Case. The risk event is called the decision tree. This technique is a way of looking at interdependent multiple risks. It also allows us to evaluate risks with multiple outcomes. For a project environment, this technique becomes extremely useful because one chosen unplanned event can often result in multiple outcomes of various levels of severity depending on the situation and on decisions made by people who are responsible for risk management. The decision tree can also be useful for us in our further work of developing workarounds in case of active acceptance of risk event. See risk response later in this chapter. As shown in Figure 8.8, decision tree diagrams are composed of boxes, which identify decision choices that must be made, and circles, which represent places where probabilistic multiple outcomes are possible. From the boxes, lines are drawn showing each possible decision. The lines lead to other decisions or probabilistic multiple outcomes. On the probabilistic circles, notice Figure 8.8, Decision Trees. That the sum of the probabilities of all the possible outcomes of this point equals 1.0. This is because all of the possible outcomes are included. Here is an example of decision tree analysis. Suppose a farmer must decide what to do with his land for the next growing season. He can choose to plant corn or soybeans or to not plant anything at all. If he plants nothing at all, the government farm subsidy will pay him $30 per acre. If the farmer decides to plant corn or soybeans on his land, there is some risk involved. The yield per acre depends on the amount of rainfall. Too much rain or too little rain will give poorer results than the right amount of rainfall. There is a 40% probability that the rainfall will be low, there is a 40% probability that the rainfall will be medium, and there is a 20% chance that the rainfall will be high. If the farmer decides to plant corn, the yield per acre will be $0, $90, and $50, respectively, if the rainfall is low, medium, or high. If the farmer decides to plant soybeans, the yield per acre will be $40, $70, and $20, respectively, for low, medium, and high amounts of rainfall. As shown in Figure 8.9, the decision to be made is whether the farmer should plant corn, soybeans, or nothing at all. There are 3 lines coming out of the decision box to indicate the 3 choices. Each choice leads to a probabilistic occurrence. How much rainfall will occur? Figure 8.9, Example, Decision Tree. Each probabilistic occurrence has 3 possible outcomes: low, medium, or high amounts of rainfall. For each of these events there is an associated payoff. The payoff amount multiplied by the probability of that event occurring is the expected value of each occurrence. In order to evaluate the decisions, we must add the expected value of each event associated with each decision to get the expected value for each decision. For corn, low rainfall means that no money will be made from the crop. For medium rainfall there is a 40% chance and a $90 yield, giving an expected value of $36. For high rainfall there is not as much yield per acre at $50 and there is a 20% probability of that occurring. The expected value for high rainfall is thus $10 per acre. Adding the expected values for the events gives us the expected value for the decision. This is $46 per acre. Using the same calculation for the soybeans and for not planting at all, we see that of the 3 decisions, planting soybeans has the greatest yield,